Hey, as if you haven't heard enough of me today, I'm going to present our NOC as well this time. And basically just going to go through the Flash presentation template, talk about the NOC structure, the network and services, NOC frontend, and inter-NOC communication, and the funniest thing at the last, documentation. So the NORDUnet NOC can be seen from a little different angles. We have something we call new NOC, which is, well, NU comes from the NORDUnet, but we see that a little more as a service, because as NORDUnet is serving the Nordic NRENs, or actually the Nordic NRENs are owners of NORDUnet, so they are our main customers. So from one point of view, we see new NOC as a service which includes the NOC, which is a separate group, an IP department, which is primarily focusing on engineering and design of new services and things like that. On the mostly layer 3 level. And then we have an optical network department as well, which is focusing on the transport network. So the thing is that the network operations center and the IP department they are located physically in Stockholm, which we have one office, and then the optical network department is located in Copenhagen. So from one point of view, that is the NOC when we sell it as a service to others. But I'm mostly going to focus on the actual NOC group, which is the NORDUnet NOC, which again has a little different hats on it, because primarily they are monitoring and taking care of the NORDUnet network, which covers the 5 Nordic countries. But as we are sort of, how should I put it, reselling the NOC service to others as well, they are also taking care of the Swedish university network. So they are both an NREN NOC and sort of a transit network NOC. So they have to switch hats from now and then, which works fairly well, I would say. They're very, very competent people that work there, so they do it really good. But the inter NOC communication makes it sometimes a little harder when you have a distributed organization. So because the optical network department takes care of a lot of some troubleshooting and some design of the network, they need to communicate very closely, but when you're not in the same physical location, it demands a little extra. But I'll get to that later on. So basically, the NOC is available 24/7, but the actual NOC group is we're only actively monitoring, and with active monitoring I mean sitting watching the screens from 7 in the morning to 7 in the evening. And all other times of the days or in weekends or holidays, the phone is redirected, and we have classified all our alarms so that all the critical alarms, or actually we classify our services. So the critical services, they send alarms forward to the on-call person. So basically, activating the on-call is manual. So every evening when the last person leaves the NOC, he or she basically runs a script saying which person is on call. This script then reconfigures the telephone and puts in some email aliases, which makes the alarms and the phone call reach the person who is on call. And then the IP and the optical network departments, they are both sort of on they are also available. Usually the NOC can handle the issues that comes in, but they have the possibility to outside office hours escalate issues, and that is also done manually. They basically, the IP and optical network team, they have a list of who is on call which week, so the NOC person on call knows or checks this list and call the person who is responsible for escalations. The NOC has 6 dedicated personnel working in shift. As a side note, there in the IP department there are 5 persons, and the optical network department also have 5 persons. But those two, they are working on strictly office hours. So the functions performed by the NOC is they do a lot. Their primary jobs are the monitoring, troubleshooting. They do some provisioning as well, and they take part in some of the planning of new services. So the idea is that we always try to have one person from the NOC when we in newer project. That way the information dissemination is a little easier, because there's always going to be at least one person in the NOC, not only being able to push forward their ideas when we design new services, because they usually have a completely different mindset than people that don't have to take care of operation that much. But also it helps when we actually hand over the service to the NOC from any of the other departments. Then they have someone in the group that has a lot of knowledge about the design already. But generally, most of the design is done by the IP or optical network department, with the participation of the network people, network operations center. So the network, NORDUnet network, is primarily consists of the colored links you see here. So the NORDUnet network, we have basically a POP in each capital city of the Nordic countries. So there are connections from Stockholm to Helsinki, and then there's a triangle from Stockholm, Oslo, Copenhagen up to Stockholm again. And then we have links to Reykjavik on Iceland. And we also have some, I think it's now least lambdas to SurfNet. So we're actually, our connections to Jaunt is, our primary connection is in Copenhagen, and then we have a backup connection in Netherlands, and then it goes through SurfNet and up to NORDUnet network. But the primary network consists of Alcatel light managers, they call it. So that's the DWDM equipment, and I think there's about 50 of those around the different countries. And then as a layer 3 equipment, we run Juniper routers. So we more or less have Juniper routers in each of the capital cities. And then, but that's the dark fiber, and as I said, our primary service is the IP transit. This is actually our IP transit, but our main service is the IP transit to our NRENs in the Nordic countries. So basically, we're acting as a transit network. But we have a lot of other connections as well. We've been working a lot later in the sort of with our peering strategy, being available on peering points, and the NOC is involved a lot in that, with setting up new peers and monitoring all our peering traffic. So For a couple of years ago, 2005, the NORDUnet NOC was outsourced completely. And at that time, we basically only had, or the NOC at that time only had the IP transit service towards our NRENs. So that was more or less the only thing they did. They took care about the layer 3 network. However, since then, I think it was 2006, we in-housed the NOC, and the last couple of years, there's been a huge amount of new services that we have been running, which puts a lot of extra demand on the NOC as well. So as you can see, I don't know if you can read this. I'm not going to go through all of them, but you can look at my slides later on. But there are, as I said, from the NOC point of view, they have to sort of take on different hats. So first of all, we have the NORDUnet network that they are NOC for, but we're doing a lot of services for SUNET, which is so from that point of view, the NOC also monitors the dark fiber network in Sweden, and which is built from Sienna equipment and also Juniper. So there's a lot of fiber there. Sweden is fairly long, so there's a lot of fiber and equipment that they're monitoring and making sure works all the time. So except the on top of the dark fiber network, most of our services that we're running now is hosted on virtual machines. So we had a couple of years ago we had an SEN infrastructure, but last couple of years now we're running VMware, and mostly due to simplicity, we're trying to migrate everything to only having one virtual platform. So there's only a few servers left on the SEN infrastructure, but soon everything is going to run on VMware hosts, unless they need a physical server. But we try to avoid that to make life simple. Monitoring is primarily for our server services. So basically, everything that runs on servers, we use Nagios to monitor. And Nagios then also both creates reporting for services that we can use later on to match to SLAs, and also sends all the alarms and redirects depending on the critical level of the service and the alarm. The alarm can be either sent to the regular NOC mailer or an on-call person. Sino is a home-developed tool, monitoring tool for network services. It's based on SNMP polling, so that's mainly used for our routers and layer 3 services. But we are using the proprietary vendor systems for the transport equipment. So both for Alcatel and Sienna, we have the NOC have separate systems to monitor everything. However, we are integrating. We've used for the Alcatel, they have something called the IOO interface, which we have interfaced to Sino. So some alarms from our transport equipment is sent to our regular SNMP polling alarms as well. So the front end, as I mentioned, we primarily serve the Nordic NRENs, but also other Nordic organizations like the NGGF, which is the Nordic Data Grid Facility, basically the tier 1 for the LHC in the Nordic countries, and some federation services like Kalmar is one of the, or WAFE, Where Are You From, which is the Danish federation for identity federation. And they're usually in contact with network engineers, so it's fairly high-level communication, especially towards the NRENs, because they themselves have really good NOCs. But from the point of view on the SUNET, there are some talks to universities, but they don't. There's no sort of end users as students or something like that. The SLA depends on the service. If it's one of the identity providers they're helping, that's a fairly short, maybe 5 lines with availability and time we are operating and such stuff. But if, for example, in the SUNET case, when we have a lot of responsibility for the Swedish NREN, there's quite a thick contract with very detailed SLA. So it depends a lot. The ticket system, I'm not going to talk too much about it today because I have a slot for that tomorrow. So I'm going to give you some more interesting details. The only thing now is that basically we use the ticket system to send out to everyone that wants to know about problems. And we use a wiki called Confluence, which is an Atlassian product for all our documentation. So inter-NOC communication, mainly because, well, main communication is email or instant messages. As we're distributed in different physical locations, you can't always just walk over and talk to them, so you have to use email or phone, but people seem to like email or instant message better. If there's a major outage, usually the chat room dedicated for that pops up to help troubleshooting if more people than just a NOC needs to be part of the troubleshooting. And communicate with service providers using emails. We again track their ticket system, so the NOC gets all their tickets, and we use from our own ticket system. We retrieve reports regarding failure. So, for example, we have SLAs towards the providers with downtime for fibers or equipment, and all those reports are generated from the tickets, and then we use those reports in our sort of monthly follow-up meetings with providers and make sure they pay their penalties. We use tags in the header of the emails to allow customers to filter out tickets. Documentation, most fun of all. We document everything, or at least we try to document everything. It's hard. It's not the most motivating job, so people tend not to always do it. But the main things are the relations we have to our customers, suppliers, all contact details and information about them. Our equipment, design of the network and services. It's important for our troubleshooting. Projects as well, what happens, what is supposed to happen further on, and sort of hand over information to the NOC. All the procedures and all the different softwares. Also, usually the software is part of the service documentation. The wiki is really our main source of documentation, and currently most of the documentation is done manually. We're working on developing a network inventory which actually polls both equipment and services automatically. So we're trying to integrate this a little more to get more automatic documentation, so that something than manual work keep tracks of all the servers and the services running on those servers and the network equipment, the topology. But so far we're only in the starting phase of that.